thanks for coming, y'all. We're here on the ground in Concan, Texas, in the path of totality with our two excellent eclipse experts. We've got Dr. Kate Russo here, who's a psychologist, author, and eclipse chaser. This will be, I believe, her 14th experience of totality. And Clara Moskowitz, who's our senior space and physics editor at the magazine. And they can speak to you on many different parts of the eclipse and the eclipse experience, the science of the eclipse, how do communities plan for eclipses, the psychology of it, how does it affects us. There's a lot of different things that they can answer, so please feel free to ask any question you have. We've got some questions prepped as well, and we'll get them started right away. Thanks for coming. All right, why don't you just start by talking about where we are and how you're feeling about this eclipse, and what even is an eclipse?
Well, we're here at Garner State Park, which is one of Texas's most popular parks, and so we're 2 days out from the total solar eclipse, so it's pretty exciting.
Yeah, and I'm here with the Scientific American team to give you updates and live coverage, and we are going to do everything we can to get you a live view of the totality on Monday. The weather here in Texas is very touch and go, so we are checking forecasts constantly, and keep your fingers crossed for us.
Okay, amazing. Someone's asking if you can see the eclipse through a phone. Would you be able to do that? Is that a safe thing to do, or do you have recommendations for how to look at an eclipse or take pictures of an eclipse through a phone?
Do you want to take that, or?
Oh, sure. If you're in the path of totality, you can view it safely, without a phone. So I'm not sure if you're going to be in the path or outside of the path, but you'd want to use solar filters to protect your eyes when you're looking at any part where the sun is visible. And so if that's the same case with your eyes, you also want to use solar filters to protect the lenses in your camera as well.
So if it's the partial eclipse leading up to totality, a little hack is to put your solar glasses in front of your phone camera, and then you can use your phone. And then during full totality, just as you can look at it with your naked eyes, your phone is also safe to point at full totality.
Yeah, nice. So how do eclipses happen for planets with multiple moons, or do eclipses happen the same way on other planets? Clara, maybe you can take this one?
Yeah, so eclipses theoretically can happen anywhere, and if there's multiple moons, they might get more chances. But the interesting thing is that you don't actually get eclipses on any of the other planets in our solar system, because Earth is in this perfect place where the moon and the sun appear to be the same size in the sky. And if you think about it, that's pretty weird. It's actually just a total cosmic coincidence, because the moon is 400 times smaller than the sun, but it's also 400 times closer than the sun. And we happen to get the exact perfect size to block out the face of the sun, but not that beautiful corona that we get to see during totality.
Do either of you know how far back in history eclipses have been documented?
I mean, I think, it goes back extremely far. Like, we even see cave paintings that suggest that people might have been seeing eclipses because they draw these beautiful kind of flare shapes that some people say are the view of the corona, which they only would have been able to see if they had seen a total solar eclipse. But the interesting thing is, they're not going to last forever. In about 620 million years, eclipses will become almost impossible or only very rarely possible to be seen, because the moon is getting farther away from the Earth a little bit every year, and eventually it's going to be too far, so it's going to be smaller and it won't fully block out the face of the sun.
There's a question here for Dr. Kate. So this will be your 14th totality. How many eclipses can one see in a lifetime? How have you seen so many?
We can never see enough eclipses in our lifetime, and I think that's going to be a sad day when we can no longer see them from Earth. I started chasing eclipses in 1999, and since I became so obsessed with them, I've tried to see every single one that I can. And because eclipses happen, a total solar eclipse happens once in every 18 months, somewhere around the world, we have to chase them. And so I try and get into the path every single time. And so that's the default setting. I will always try and be there. But sometimes life happens. Sometimes the circumstances means that you can't travel, you have to miss it. It might be too expensive. So I have missed one or two of them, but I tell you what, I will be chasing for as long as I can. And yep, until I can't do it anymore. That's the plan.
Can I ask a question for Kate? What is the most remote eclipse you've seen? Where, what's the farthest you've had to travel?
Yeah, well, remote's interesting because, you have to be prepared to travel anywhere, right? Probably outer Mongolia was one of the remote places because Mongolia is an interesting place. There's not like a lot of roads that you can get to. So you actually are traveling over land and, just no resources, no facilities or anything. And so to me, that was quite remote, and that was near the border of Kazakhstan and Mongolia. Another really remote place was in 2005 for the hybrid eclipse that happened over the Pacific Ocean, and only 2 cruise ships were able to get there, one from Tahiti and one from the Galapagos Islands. So I was on the one in the Galapagos Islands, and the Galapagos Islands are 800 miles off the coast of South America, and then we had to travel a further 800 miles out. Now that's a really remote part of the ocean. It's not in any shipping lanes. It was very, very remote. So I would say that's probably the longest, the most remote place ever.
It's amazing.
Yeah.
Someone here is asking, can we see totality with the naked eye?
Yes, you have to. That's one of the things. Sometimes you see video clips of people enjoying the totality and they still have their glasses on. But actually, you don't need your glasses because the moon is acting as the filter. The moon is protecting your eyes from the sun, and that's what causes the beautiful corona around the sun. So you must take your filters off during totality and see it with the naked eye. If you are in that path of totality and the moon and the sun is 100% covered, you have to look at it with your naked eye, and it is the most beautiful sight ever.
Yeah, do you have any standout moments of your experiences of totality?
Oh, there are so many.
Or perhaps a better question, after you've seen it once, why go see it again and again and again? Is it unique and different every time? Yeah, why?
Yeah. And I think we're asked that a lot because if you think about it, the celestial mechanics is the same, right? It's the same processes that happens. The moon slowly moves in front of the sun, the total eclipse happens, and then the moon continues until they're not connected anymore. But there are so many differences. So the path of totality always goes over different areas, and you could be in a position along the path where you're seeing it at sunrise or in the middle of the day or at sunset. And so sometimes you're looking right up, like we will be in 2 days' time. Sometimes you're looking on the horizon and you're seeing it, and you can see the moon's shadow, the cone of the shadow. Other times it's cloudy, other times it's brilliant sunshine. You're also experiencing it with different cultures and people you've never met before. There's usually lots of interesting things that you can do as well. So we don't just visit a place, see the eclipse and go. Often, you experience culture and how people make sense of it. So every experience is a unique and different and wonderful. So they are very different, although there's that similarity that still happens.
If I can say, so I don't have nearly as much experience. I've only seen one in 2017. And beforehand, I thought it was going to be cool. I was really excited. I thought, I'd check off that list on my bucket list. But once I saw it, I was completely blown away. I was not expecting the experience. And Kate has described it as, I really liked what you said. It's not just something you see, but you said what you said.
Yeah, you experience totality. So you never just see totality, do you? And even though you know what's coming, even though you know what's going to happen, it still takes you by surprise. So I always say it happens above you, it happens around you, and it happens within you, because it's fully immersive, isn't it?
Exactly.
It's unlike anything else.
I burst into tears, which was a bit embarrassing. I didn't mean to. I was overcome. And I think that people that get often taken by surprise like that.
Yeah.
Oops. Seeing a little flashing on the Instagram. Let's see, what is going on here? Oh, okay, it's fixed itself there. Another person is asking, how do clouds affect your experience of the eclipse, and maybe also how does an eclipse impact cloud cover on the day of?
I'll do the first one then.
Sure.
So, because the eclipse happens, the totality happens above you, around you, and within you, If there are clouds in the way, that actually impacts upon what we see. And it depends on the type of cloud too. But if there's low cloud that really covers a lot of what you see, you don't actually get the visuals. So during totality, what we like to see is the moon moving in front of the sun, and the Bailey's beads and the diamond ring, which are really beautiful features that start and end the process of totality. But also seeing the sun's corona, the outer atmosphere of the sun. It is beautiful, and this is the only time that we can see this. And if there are clouds in the way, you don't get those visuals. And we also don't see the darkening of the sky. We're not able to see the planets and some of the brightest stars. So there's a lot of the experience that you don't get if it's really thick cloud blocking the view. And so without those visuals, without all the things that happen above us, a lot of the experience, a lot of the immersive experience it's not as impactful as an emotional experience. But we still happen to experience the things around us. So we will notice the changes of light. We will notice that the temperature will drop. We will notice the change of the birds and the insects, and we will hear the people around us. We'll be able to see the sunset colors all around us if we're in a spot where we've got an elevated view. So there are things that we can still experience, but it's just not the full experience when there are thick clouds in the way.
Now, if you only have partial cloud cover, especially if you don't have low clouds, but you just have some high clouds and intermittent, then you may still be able to see it. And in fact, some people say that's the coolest view, is where you have the sun peeking out in between a little hole in intermittent clouds, and you might even see a little wispy cloud in front of the eclipse, but you'll still be able to see it. So all hope isn't lost with clouds. And there's even the phenomenon of the sun itself shining through clouds, so it may be able to burn off a little hole, right, in where you're looking directly at it. So it is helping you out. It's trying to make it possible for you to see it.
We're trying to be optimistic, because ideally what you want is a clear view, so you don't have to worry about clouds, because I know the presence of clouds can make it a little bit more, you feel more worried about it just in case the clouds get in the way. But having experienced that, it can be quite exciting, and so the emotional roller coaster is huge when the clouds are there, because it just adds that edge of excitement to it. We prefer not to have that, but sometimes that's the reality.
I'm just speaking to everybody else here in Texas with us.
Trying to be hopeful.
Exactly.
Yep.
And Kate, you might be particularly well poised to answer this next question. What is the psychology behind the eclipse, and maybe the awe that we experience behind it? Because it's such a visceral experience.
Yeah, it's complex, isn't it? And I think the experience of totality is something that's very difficult to describe in a way that someone who hasn't experienced it before can really understand. And it's like an embodied experience. And by that we mean that it happens to us on a very physical level. And a few years ago now, about 10 years ago, I did a survey on eclipse chasers. And I asked them, what emotions do you experience during totality? And the interesting thing I found in this survey was that everybody was saying the same thing. There was a similar pattern that people were going through. And so it starts with that sense of you're watching the partial eclipse, it's really interesting, but there is a moment that you notice that something's gone a little bit wrong, that sense of wrongness. So the light doesn't quite look the same as what it normally does. Everything's just a bit weird. There's this darkening in the sky. The wind kind of picks up or changes direction. And then you're really starting to think, this is not how the world is. And you really start to pay attention. And then moments before totality, if you're in that path of totality, moments before, you get this ominous feeling that something huge is coming, and you know it's the moon's shadow. And even though you know it's coming, it really just is so unexpected, and we have a primal fear, and it's that feeling of doom but excitement. It's a really and eclipse chasers actually use the word primitive fear, so we're using that term because it's unlike any other feeling. And for me, the hair on the back of my neck stands up. I always get goosebumps at that point, and it just, because it's so overwhelming. And then when totality happens, then we have this moment of awe. And the emotion of awe is really complex because it involves two things. We feel in the presence of something greater than us and more powerful than us. And then because of that, it makes us think about our lives in a different way. And so having those two elements together really is fundamental to the experience of totality. Then we have that feeling of connectedness and insignificance. And by that, you just feel insignificant in the world, don't you? You just sort of feel like you're part of something so much greater, and you understand that you only just play a small part. So all the little concerns and everyday life things that happen really doesn't seem that big a deal because it's so much greater. And you feel connected to something, whether it's the universe or whether it's humanity, people around you, but that feeling of connection is very, very strong. So that insignificance and connection is really empowering and makes you feel so positive. And there's a lot of research that says that when you experience that, you become more altruistic, you engage in more pro-social behaviors. So it's actually good for us. And then during totality, we also, after the awe, there's the euphoria, because we know and we can feel that it's coming to an end and we don't want it to end. And so we're just sort of like in this moment of, it's just great. And you just want to maximize that time. And then it just, as suddenly as it comes in, it sweeps away. And then you're left with this massive big downer. And we call it the desire to repeat. You know, it's you just want to see it again. You want to experience it again. And that's the most common question is, when is the next eclipse? Because that's what you feel. So that's really hard to say in a soundbite, right? So all of those things, but all that together, that commonality of experience, we sort of say that's the embodied experience of totality. And I summarize that by saying what I said before. It happens above us, it happens around us, and it happens within us.
Do you want to speak to your experience of totality at all, Clara?
Yeah, I mean, what you said really resonates, because I think that primal fear you described was the part that I wasn't expecting. And something comes over you where it's clear that something is happening in the universe that is so beyond your control and so unexpected, even though you expect it. That's why you're there. That you almost can't really comprehend it. You just feel it, and you feel a little afraid, like you said, the word ominous, and it makes me think of why we seek other thrills like roller coasters. You know, that kind of fear can be so exciting, and then the balance of that fear and the euphoria is such a high. And I think that's what overcame me when I first saw it. And exactly like she said, my first thought was, I've got to see this again. So rather than checking off that line on my bucket list, I was like, oh, forget it. It's my bucket list forever. I've got to see as many of these as I possibly can. And here I am chasing that thrill, that high again.
Yeah, here we all are. Have you heard any myths about eclipses? Is there a big eclipse myth that myths are floating around, or? Yeah.
Well, there's one really dangerous myth, which is that you can look at a partial eclipse with the naked eye. I think some people feel that because part of the sun is blocked by the moon, that it's okay, and that's a very dangerous myth, because the partial eclipse is quite powerful, just as powerful as the regular sun at burning up your eyes if you're not looking through solar glasses. So it's really important to use eye protection for every part of the eclipse except for totality. There quite a few people, a lot of people had permanent eye damage from the 2017 eclipse by not using protective eyeglasses.
And then historically, I think because in any one location, a total solar eclipse happens only once in every 375 years on average. So if you didn't chase like me, it only happens so frequently. That's generations, right, before anyone has that experience. And in the past, it was so powerful. It went down through storytelling, and I think that's the onset of where myths and legends happen. It's the storytelling of an event that was so powerful, and often it's connected to other things that happen around that particular point of time. And so it's really interesting because whenever you travel around the world to experience a solar eclipse, a total eclipse, you do hear a lot of these myths and legends from different perspectives. A commonality is that there seems to be the feeling that some groups aren't or shouldn't be able to see it with the naked eye. So whether it's women and children, or whether it's animals, or whether it's not safe for pregnant women. So I think that's a common thing that I've experienced at different places around the world. But it's fascinating, isn't it?
And historically, there have been many really cool myths. When people were trying to make sense of an eclipse before they had a scientific explanation for it. And most of those center on, apocalypse, because understandably it looks like the sun has gone away, has been blacked out, has been swallowed up. So a lot of myths involve the sun being eaten up. The sun is gone, and maybe it's punishment for our bad behavior or something that we did wrong. And the amazing thing is, even now when we view it, it's quite scary, even with a full scientific explanation of what's really going on. So you can truly understand how it would have been absolutely terrifying before you knew what was happening and you didn't have any warning.
And if people aren't able to travel to Totality this time or any time, is there any way they can get a piece of that experience? Maybe you could speak to what we're trying to do this Monday here on the ground in Texas?
Absolutely. There are tons of ways to view it online, and you definitely should check it out because you're still seeing it live. You're seeing the actual on-the-ground footage, and Scientific American is going to be bringing you a live stream. We actually have several live streams already keyed up on our page, so go to scientificamerican.com and you'll be able to find our story about all the ways that you can watch it online, so that if you're not going to be there in person this time, you can still check it out.
And of course, if you're in the US, you can actually enjoy the partial phases too.
Of course.
So while you're doing that, you can just step outside wherever you are, and then with your solar filters on, just see the progression where you are, because most people will be able to experience that on the day.
Yeah, are there other ways you can experience the partial eclipse? Like, can you talk about the shadows maybe you would see, or any experiments they can do on their own at home?
So yeah, you can, like Kate said, take your eclipse glasses, go out and just look at it and see it, a bigger and bigger chunk of the sun being eaten up by the moon, which is really cool. But you don't even need eclipse glasses if you don't have them. One cool thing is to go under a tree, and the leaves on the tree will actually act as a pinhole camera so that you can see the crescent shape of the sun reflected on the ground, the shadows on the ground, just from the leaves of the tree. It's quite beautiful. Another thing you can do is just take the colander from your kitchen, and that will be a pinhole camera. And you can look at the ground and you'll see the shadows showing you the exact shape of the partially eclipsed sun at any given moment.
And something we like to do that builds on that is make a little card, because you still have time to do this before the eclipse. Make a little card and put some holes in it and make it say something like, I like putting it where I am, like, Texas 2024. And then you use that to project the image, and it's done in crescent, the crescents actually form the words. So that's quite nice, and you can do that at home and there as well.
That's really fun. I'm going to do that.
Good.
And there's some local question askers asking, what will the timeline look like in Texas for the eclipse?
Right. So do you know what time the partial starts?
Yes, and so it varies slightly according to your location, but it's around 12. I've got the timings here.
I think it's 12:15 or 12:13 starting here.
That's, yes.
And then Totality be around 1:30.
Yes.
Yeah, 1:30,
Yeah.
1:29, 1:30.
And then in East Coast time, your Totality will be around 2:30, plus or minus 10 minutes. So check your local forecast, but it'll be starting around 1. The maximum, not Totality, like let's say you're in New York City, you won't see Totality, but you'll be seeing above 90%, which is really cool, and that'll be around 2:30 for you.
And there's stories of different types of weather in different parts of the country. Everyone's looking at the cloud forecast. Do you have any favorite ways to monitor conditions and to plan where exactly to be for Totality?
Yeah, so this eclipse has been a little bit challenging for the weather, because the way that historical climate weather records have indicated this part of the path would have been the best chance of seeing clearer skies. And then the further northeast you go, the cloudier it got. That's just general. And it's pretty much the opposite. And there are holes actually appearing in places that may not have had favourable weather in the past. So there's a lot of people on the ground who really have been quite obsessively looking at different weather apps, and it's really hard to know which ones to see. And I've been using a number of different ones, but my personal favourite is the Windy app. And I use it myself day in, day out, just normal everyday storms where I live in North Queensland in Australia. But if you go to the Windy app in the community, you'll see that people have actually overlaid the path of totality in the programming. So you're able to actually have the path, then you can check the weather across the path. And the Windy app, the reason why I like it is because you can actually look at the different levels of cloud, and you can see the forecasts that are coming. And within the same app, you've got a number of different models that you can compare to. If you're not using one app to do the different model comparisons, what tends to happen is that you're flicking from different apps to different apps, and you can just get caught in the anxiety of it, can't you? So I like now I'm sticking just to the one app. Now that we're so close out, the forecasts are becoming a little bit more accurate. So that's what I'm using.
Will California see any of the eclipse? Will it stretch that far, partial totality? Or?
There will be partial, yeah.
There will be partial, yeah. I'm not sure of the percentage, and of course it depends on which part of California. The closer you are to the path, the more of the moon, the sun will be obscured by the moon. And then further out. So I think near the border of Alaska, it might be up to about 20%.
Right. But almost, like really most of the U.S. you will see a partial. So really, wherever you are, go out and try to see it.
Yeah.
With eclipse glasses.
With eclipse glasses.
Claire, can you speak at all to the community science initiatives happening during this eclipse?
Yeah, so that's something really exciting. The eclipse is obviously just a spectacle, amazing to see, but it's definitely an opportunity for science as well, because what we can see during the eclipse that we can't see any other time from the ground is the solar corona, which is the atmosphere of the sun. And we actually don't know enough about the physics of the corona to satisfy our questions. Scientists are trying to understand why the corona is as hot as it is, because it's actually so much hotter than the surface of the sun, which is very counterintuitive. You would think the surface would be hottest and it would get cooler as you move away, but that's not what happens. So there's a lot of projects that are going to be studying the corona. One of them is called Citizen Kate, and there's stations planted all along the path of totality where regular people are going to be taking photos of the eclipse, and they're going to combine all these photos to create one of the best views they've ever had of the corona, and study the physics behind it. Another cool project is called Sun Sketcher, and you can download this on your phone. If you're going to be anywhere in the path of totality, you just set up your phone pointing toward the sun, and then you leave it alone. You don't even have to do anything. It'll take pictures during totality. And the goal of that one is actually to figure out the shape of the sun. Obviously, it's round, but it's not perfectly round, which is cool. And if they can figure out where it deviates from being perfectly spherical, they can figure out the physics of what's going on inside the sun. And they're going to combine these pictures from people all across the path to make the most accurate measurement we've ever had of the true shape of the sun. So that's pretty cool.
That's so cool. Can you repeat again the app you like to use for weather forecasts, and also mention how people find out where the path of totality exactly is?
Yes, so it's the Windy app, so Windy. And I don't know if it works so well on the mobile phone. I mean, I use it on the mobile phone all the time, but I found that with the path of totality overlaid, I had to go onto my laptop. And then there is a button there about community. So, and people are actually uploading all sorts of interesting files that you can have as the background with the app. So there are many people who've done that with the path of totality. So have a look through that, and then you'll find it there.
Yeah. And I mean, this eclipse is cutting across a huge swath of the country, and people are traveling from all over to the path of totality. How do communities prepare for eclipses that are passing through their towns?
Yeah, this is a big deal for communities. Do you remember, in any one location, it's once in every 375 years. So that's why they say it's a once in a lifetime experience. Because if you're not someone like me, if you just sit and wait for a path of totality to go over you, it's a once in a lifetime experience. And so if you're a community that's within the path of totality, it's likely that most of the people have never before experienced it, and they don't really know how amazing it is, that it's going to be as big as it is. And so you almost need someone from outside to actually alert them to say, hey, this is actually coming to you, and it's a really big deal, and it will be one of the biggest events that your community would be hosting. And so sometimes communities have to start planning years in advance to be able to manage a lot of the impacts of people coming in, because people will come from all over the world to get into the path of totality. Now, this path of totality is unique because across the US alone, there's 3,000 communities in the path. I mean, that's a huge amount. In 2017, there were about 1,000 communities in the path of totality. So many more communities here. But there's a lot of places where people can go and spread out. So it's not like one place is going to be inundated with every single eclipse chaser. So lots of space to spread out. But for communities, they really need to know how to prepare, who's coming, how are they going to cater for all the people, what happens, what to expect. So it can involve a lot of agencies all working together that don't really necessarily have worked together before.
Should people expect major traffic jams and things like that if they're in the path?
Yeah, and I think that's one of the biggest challenges, isn't it? Because the people coming into the path of totality, if you're in a heavily populated area, there will be a huge number of people traveling in and then traveling out. But what we tend to find is traveling into the path, people tend to stagger their arrival. So some people arrive a week before, some people in the days before, some people will travel in on the morning. But everybody seems to want to travel at the same time. As soon as totality is over, they're in their cars trying to beat their traffic, just like you see in any other big event. And so we saw that from 2017. There are a number of major traffic jams that took 10 hours to clear. And so armed with that knowledge, a lot of people now are prepared for that. And there are some really good campaigns in high population areas, like Take Tuesday 2. That's very much happening in New York State. And so those are the sort of things that really do need to involve planning. So, and if you are traveling into the path and out of the path, you just need to be prepared, especially coming out of the path, that it's going to be busy. You need to make sure you've got enough fuel, because some people did find that they were on the road for hours and hours. Have some supplies with you just in case that happens. And don't be surprised if there's a lot of people on the road. But lots of planning, and there's a lot of coordination, and I think we can have a lot of faith that things will flow smoothly. It's just going to take a bit of time to clear.
Can you tell us again where we are and specifically where we are, and then also how do we find out where the next path of totality is, or where the next eclipses will happen?
So right here we are in Garner State Park, and that's in Uvalde County in Texas. And we're not too far from the border here, and this is one of the premium locations for the Path of Totality. And this is the reason why I really wanted to come here. And it's actually in a unique place because in October last year, there was an annular eclipse that also came through Garner State Park. So we were in the eclipse crossroads for these two eclipses. But we are here now. We are pretty close to the center line. We will have 4 minutes, 26 seconds of totality where we are here. And if you're looking for information about future eclipses, I think a really good website is greatamericaneclipse.com. Now, the man who runs that is Michael Zieler, and he is an eclipse chaser, but he's also a cartographer, and he does really, really beautiful maps about a whole, like so many maps, you couldn't believe it. And if you're someone like me who loves maps and loves travel, I mean, you could spend hours and days on his website. He's so much material. So he's got lots of information about the future paths.
Also, a plug, if I may, at scientificamerican.com, we've created a graphic that shows all of the upcoming eclipses that will cross over the U.S. in the next 100 years. And you can see where those are all going to be and plan your next one.
Mm-hmm. And let's see, what else? Can you walk us through the stages of an eclipse and what your experience might be at each stage?
Mm-hmm. All right, so it starts with first contact. And that's the point where, it's amazing how we know exactly the right time. So, once you know where your location is, you'll be able to pinpoint that exact moment to the millisecond. And when you're on the ground observing first contact, it's actually quite tricky because you know it started, but you can't actually perceive it until a few moments later. And there's always, you have to use your filters because at that point it's the whole sun you're looking at. And so through your filters, what you notice is that there's a tiny, tiny sliver and there's always someone in the crowd who spots it before me. Like I can never spot it first. And then you think, is it? And you have to just wait a minute or two, and then it starts to become really clear. And it helps if you know where, in which position the moon is going to first make contact with the sun, so you know exactly where to look. But I think when I feel that moment where I see first contact happening, the first visual of that, it's really exciting, because you've been building up to that point for so long. You've been planning an eclipse chase for so long, and it's actually here. And it's started, and no matter what happens, you are there in the path, and it's about to happen. So that's a really good point to celebrate. And then as the eclipse progresses, because there's the moon and the sun are constantly in motion, but you can notice the progression of the moon covering more of the sun as time goes on. And that takes about an hour or so before that full progression happens. And it's during those moments that you're noticing over time the changes. And our eyes are really good at adjusting to the changes in light. So really it takes quite a lot of the moon covering the sun before we pick it up. And so perhaps it might be 70 or 80%. Then you start to notice something about the quality of the light that's different. And I love that moment. And I can't stop myself from saying, look at the light, look at the light. It's just so unusual, isn't it?
Twilight in the middle of the day.
Yeah, but it's sort of like the colors are fading, and it's just unlike anything you've seen. It starts to feel like you're a bit on a movie set, I think. And then the closer you get to it, the more dramatic that feeling is. And of course, that's when you can notice, as you know, the more of the sun is covered, the crescent sun that is projected onto the ground, they become much more noticeable and obvious, and your own shadows can become a little bit blurred too. So if you put your hand out, on one side the shadows are quite sharp, and on the other side it's quite blurry. So there's some pretty cool things like that you can do. And then second contact is actually the point of totality. So that's the point where it starts, and it's triggered off by the Bailey's beads and the diamond ring. So do you want to explain those?
Sure. So for a lot of people, that's one of the coolest parts of the whole thing. This is the very first moments when the moon starts to fully overlap the sun. And what you see, because the moon is definitely not a perfect sphere. If you picture the edge of the moon, it's got craters and mountains. It's very rugged. And so what you see is that little beads called Bailey's beads of light are able to pop through in certain spots of the moon, but are blocked in others where it's higher, the land is higher. And so you get these beads, and then at the very last moment you get just one bead, maybe just the last bead, and it creates this ring. It spreads out into a ring, and it looks like a diamond on a ring on your finger, and it's just gorgeous, right?
It is beautiful. It's almost like everything locks into place at that moment. And it does look like a diamond ring in the sky, and it heralds the start of totality, and that's the moment where you can take your filters off, and then it's totality. And then your eyes take a little while to adjust to see the detail of the corona. So the longer the time you have in totality, the more detail you see, the darker it gets. And so we have 4 minutes and 26 seconds here, which is a huge amount of time. The last total solar eclipse I chased was in Australia in April last year, and it was 56 seconds. And so it was almost like still quite bright, and it took a little while for me to actually really notice the detail of the corona, because it was much lighter. So here we're going to notice so much more, and we'll have lots of time to be able to look at the corona in detail. And so that's great that is that amount of time. And then third contact, it's almost like everything happens in reverse, and that signals the end of totality. So do you want to explain that?
Yeah, and I will just say also about the corona that it's quite special now, because the sun...
What is the corona?
The corona, again, is the outer atmosphere of the sun. It's the wispy white flares that we will see during totality. You'll see the black face of the sun covered by the moon, but the atmosphere of the sun is peeking out. It looks like these clouds almost, but what that really is just this amazing phenomenon that happens around our sun, and it changes. So it flares, it wisps, it blows, and it's all because of the magnetic field in the sun, which is one of the most complex things physicists have ever tried to study, because it's all wrapped up. The magnetic field lines are just tangled and wrapped up and constantly moving and constantly driving movement and changes within the corona. And that's what we can see with our naked eye. And that's also what scientists are going to be studying. And last time in 2017, the sun was at a less active stage in its cycle, so it's quite active now, and it should be a really good show. But then again, yes, we start to see these beads of real sunlight, of the actual face of the sun start poking out from behind the moon. And again, they come just in little droplets because of the topography of the moon being very rugged and uneven because of the craters and mountains that you have. And so at first you just see beads, and then you start to see more of a little crescent of the sun coming out, and you're back into partial solar eclipse territory.
Dr. Kate, how old were you when you saw your first total solar eclipse, and what was the first experience like?
How old was I? Oh my goodness. I think I was about 28, something like that. And it was something that I wanted to see an eclipse for a long time. And you just get caught up in your normal everyday life. I was doing lots of study, and then I moved overseas. And so it wasn't until then that my life was a bit more stable that I then thought, right, let's have a look to see where the path is. And it wasn't too far from where I was living in the UK. So the path in 1999 went across the south of England and across a lot of Europe. And so I decided to go to the coast of France to see it. And I thought it was actually only going to be a one-off thing, that it was something I wanted to do, and this was the time to actually do it. I didn't know too much about eclipses, or I didn't even know anything about the fact that, the weather might impact on what you see. It was just get into the path, see the eclipse, and then that's something that I've done. But even though I'd wanted to see it a long time, even though I knew what was going to happen, I knew we were going to be cast into that darkness, I understood what was going to happen. It just took me so by surprise. I just had no idea that it was so immersive. I didn't have any idea that there would be those emotional responses to that, to the shadow coming through. I just had no idea. And even though you hear that the experience is something very powerful, you just truly cannot understand it until you experience it. So it's not like something where, we hear all the time that it's a supermoon, and then you go out and you have a look and you think, yeah, that's cool. It's not like that. Yeah. It actually is on a completely different scale. It is truly remarkable. So that was my first experience, and I remember being so emotionally overwhelmed, I couldn't speak. And when I get emotionally overwhelmed, my throat closes up. I don't find the words to describe it. And I was looking around people after me, and there were people in tears, and I just knew at that point I had to see the next one. And we didn't have smartphones back then. And so I had to wait about 5 days until I got home, and then I could Google at home when the next one was. And I just thought, yep, I have to be there. No matter where it is in the world, I am going. And that's what I've been doing ever since.
Yeah, where is the next total solar eclipse going to happen?
Yes, so us chasers always have many in we plan for multiple. So the next one is happening in 2026, and it's on August the 12th, 2026, and it goes across Greenland and across the tip of Iceland, and then across Spain and the island of Majorca. So it's a really nice eclipse that's going to happen there, and I'm looking forward to that. I haven't started making my plans because I've been so immersed in this one, but I know that it would be fantastic to go visit Greenland at that time of year, but I think realistically where I am and what's needed is I probably will see it from Spain.
Do you know how many minutes of totality that eclipse will have?
Oh, not right now, but I know the following eclipse in 2027, that's going to be a really, really long one, and that goes across north of Africa. Do you know
I don't know the
length of time?
Duration, no.
Yeah, I normally do, but we're so close to this eclipse, and I've been doing lots of talks in different locations, so the timings I'm just not as familiar. I don't want to say anything that's kind of wrong.
And the next eclipse over the US will be in 20 years, 2044. That one will go over Alaska, parts of Montana, Canada, and so that's the very next chance. But the very next year, 2045, there's going to be an eclipse over more of North America. So another broad swath of the U.S. will be able to see one, but we've got to wait 2 decades for it.
And if I can say how lucky we are in Australia, I live in Australia now, and we have 5 total solar eclipses in the space of 15 years. And the first one of that was in April last year, but we have 4 more in 15 years.
Amazing.
So in 2028, 2030, 2037, and 2038. So guess where we will all be? Come down under.
Will you actually go blind if you stare at a partial solar eclipse?
You will not go blind, but you will damage your eyesight, and you'll have dark spots in your vision forever after, potentially. And the dangerous part of it is that it doesn't hurt. So you might not think that you're doing any damage. You might look straight at the sun for a few minutes and be like, oh, look, I'm doing it, no problem. But you won't notice until later, maybe the next day or two, you'll have fuzzy vision, and then in a few days, you'd be like, there's a persistent dark spot in my vision that won't go away, and that's the permanent eye damage.
And it's kind of uncomfortable when you look at the sun. We all have that reflex. It's a look away reflex. So, you know, when you see it bright, we don't want to look at the sun. It's just during the eclipse, our attention is drawn to it. So people are thinking there's something happening with it. We want to have a look. So the only way you can do that safely is with your solar filters.
And you know, I think we're just going to be doing this for another 15 minutes or so, but I wanted to do one more reintroduction for anyone else who is new here. This is Claire Moskowitz, our space and physics editor. This is Kate Russo, who's an eclipse expert, an author, a psychologist who's seen 13 total solar eclipses. And so this is your last chance to ask them any question you want about the eclipse. So throw them in the chat and we'll get them answered. I have another question here. Can you look at when the Bailey's beads appear, those lights next to the eclipse, can you look at that with your naked eye, or should you still be looking through eclipse glasses?
You should still be looking through eclipse glasses, because those beads of light, although they're very small, are coming directly from the full face of the sun, and that kind of light can damage your eyes.
And I think experienced eclipse chasers, it's the diamond ring that's the herald of, because that's the very first Bailey's beads, and I think it's that thing of once you see that diamond ring, glasses on.
Yeah, so it's okay to look for a moment maybe at the beads and the ring without the glasses.
Yeah. But if it's your first one and you're not sure, err on the side of caution. Yeah.
Why are there about to be so many eclipses in Australia?
We're the lucky country. Coincidentally, just sometimes the path of totality falls in different places. You know, like sometimes you can have the crossovers. So in 2017 and 2024, places like Carbondale and Illinois are lucky enough to be in those the eclipse crossroads.
Yeah, they're pretty randomly or evenly distributed around lots of parts of the Earth, right? But, you know, quite a few are in really remote places over the ocean that nobody gets to see except for like 2 cruise ships, as she told us a story earlier. So, you know, it's rarer that one goes over such a broad swath of populated land.
And Australia's quite a large continent too. It's like the US. So yeah.
Is there any change in the gravitational force between the Earth and the Sun during an eclipse?
No. Sorry, I shouldn't answer so abruptly, but no, I don't believe so, because, you know, the gravitational force is just completely unaffected by the light. This is about the mass of the sun, and the mass of the sun is still there. And when the sun and the moon are aligned, you do have the combined gravitational force of both of them pulling in the exact same direction. So there's a little bit of an effect on tides, you know, if you think about it in the moment, but nothing noticeable, because mostly everything on Earth will carry about just as if things are normal. It's just the visual spectacle.
Mm-hmm. And why does the length of totality differ from eclipse to eclipse?
Do you know?
You answer that and I'll add in.
I think it's purely about the alignment. So, you know, if the length of totality has to do with how long this perfectly round face of the sun is blocked by the face of the moon, and the geometry and alignment, some places are directly in the path and then you get the most, but you're still in totality if you're a little bit off that direct line of the axis where the two overlap, you still get totality, but not for as long because they're not overlapping perfectly for quite as long.
And sometimes the moon is closer to Earth. It's like the supermoon, like
Right.
we can see that. There's variation in how it's closer. And if it's closer to the Earth, that means that the moon, the diameter of the moon is bigger. And so
Right.
it's closer to the moon, to the Earth now compared to 2017, because the path is almost twice as wide. And so there could be variations there.
And you know, the thing about eclipses that they actually wouldn't be special at all if the Earth's rotation and the moon's rotation were aligned, because then you would get, every time you had a full moon, you would get the perfectly overlapped sun. It's because of the tilt of the moon's rotation that it's only sometimes that it's the perfect distance, to be not too far away, to be too small, and not too close to be too big, but just the perfect distance to block out the full face of the sun, but no more.
Right, and you mentioned there was an eclipse in the same location last year in October, but it was a different kind of eclipse. Can you explain that?
It was an annular eclipse, and that's not annual. An annual thing happens once a year, but an annular eclipse means that it's a ring. And so the moon is actually further away from the sun at that point where the alignment happens. And so instead of the moon fully covering the sun, it's left with the ring, the outer ring around it. And we call that the ring of fire. And so it's interesting, but here in this location, there was still 91% of the sun that was visible in that ring. So there was never a point that we could see it with the naked eye. We always had to keep our solar filters on for that one.
Do you have a favorite eclipse fact?
Oh, an eclipse fact. Oh, all that's coming to mind, it's not an eclipse fact, it's a emotional fact. But did you know that excitement and fear is actually the same physiological response, and that the only difference is what the cognitions are behind it? But that's not an eclipse fact, but that's what we feel.
Yeah.
What's yours?
I think mine, I spoke about this earlier, but we have people coming in and out. My favorite eclipse fact is that it's just a total cosmic coincidence that we're allowed to see them at all. Because as we were just speaking, you have to have the moon being the perfect distance from Earth to overlap the full face of the sun, but no more, in order to reveal the corona, the shining atmosphere around it. And those things are far from guaranteed. There's nothing guaranteeing that the placement of the moon would be correct for that to happen. And on other planets, their moons are not the right distance to be able to block out the full face of the sun. So Earth is just lucky that we have this, and we're in a lucky spot, but we're also in a lucky moment in time, because billions of years ago, the Earth was closer to the moon, and so the moon was too big. It was blocking out more of the sun. You wouldn't have seen it. And in about 620 million years from now, the moon will be too far away from Earth. It's gradually moving farther and farther every year, and it'll be too far away that you'll just get the annular eclipses that Kate was just talking about, but not the full totality.
And I think, coming back to that question, it's one fact that blows my mind, and it's that idea that that darkness that we're in, it's the moon's shadow. We're in the shadow of an object that's out there, passing between us and the sun. And do you know when you can be outside and it's a cloudy day, and so you're standing there, and then the cloud covers the sun, and you know you're in the shadow. This is on such a grand scale, and it always blows my mind, that idea that this is it's like the universe opens up in 3 dimensions, because we're in the shadow of the moon. The moon is out there, and then how vast is this universe from there? Completely blows my mind.
I'll tell you one more bonus fact I just remembered. I think one of my real favorite things about eclipses is that they're so important for science. We talked a little bit about how they're a chance to study the solar corona, but they've done a lot of other things for science too. And my favorite is that they proved Albert Einstein's general theory of relativity. So if you recall, a little bit more than 100 years ago, Albert Einstein completely revolutionized what we thought gravity was. And he described it as curving space and time. The presence of a massive body like the sun actually makes the space and time around it curved, and any object traveling in the path is going to follow a curved path, and that's what gravity is. But not everybody believed it. We had no way to prove it until a few years later there was an eclipse, and scientists mounted an expedition, and they were able to use the eclipse to prove that Einstein's general relativity was correct, because during the eclipse they could look at the positions of stars right nearby it, and they were able to see that the light from the stars was bent off their normal course. They did not appear the way they usually appear in the sky when the sun is not present, but the light from the distant stars had to travel around the sun along that curved space-time, and it was deflected. And the New York Times at that time printed, I think, one of my favorite headlines of all time. It said, "Men of science more or less agog," because heavenly bodies all askew, something like that. And it was a pretty amazing, stunning moment where we had to use this celestial phenomenon to predict, to confirm this prediction, this idea that we had that we didn't yet have proof for.
What kind of dip in temperature should you expect during totality?
It can be quite, up to 10 degrees Celsius, which in Fahrenheit is
noticeable.
And I think especially in hot environments, I recall being in the Tunisian desert, and it was during an annular eclipse, but it was very noticeable, that drop and change. So I think it's really cool if you do have a thermometer that you can just keep very handy and every once in a while take photos of it or monitor it. But if you take photos, you've got the time measuring too, and you can just see for yourself how much it drops in your location, even if you're just seeing it from a partial phase.
Right, you'll still see a noticeable drop even if you have 70, 80, 90%.
Yeah. But it always sometimes changes the wind direction. It changes the environment and it changes the wind direction. So sometimes people get caught out because it does drop so much that you need a little jacket or something. Yeah.
And it does feel and look like the middle of the night, which is one of those cool things about the experience that you don't totally expect. And the animals around us can be very confused because it seems like night has occurred suddenly in the middle of the day. And crickets come out, nighttime animals start coming out and saying, "Oh, it's my time to shine." And then a few minutes later, they're like, "Oh, I guess it's daytime again."
It's very confusing.
Morning has come. Yeah.
Where can folks find eclipse glasses, and can you just use regular sunglasses?
Definitely not regular sunglasses. Eclipse glasses are much more like welder's glasses. If you look through them, it's completely black. The only thing you can see is the sun. So regular sunglasses just do not block enough of the sun's light to keep your eyes protected for you to be looking directly at any part of the face of the sun, even during the partial eclipse. And you can get eclipse glasses at a lot of libraries. They're giving them away for free. And a lot of glasses stores, I know Warby Parker stores are also giving away eclipse glasses, and you can order them from reputable dealers, although we're getting quite close to it. But if you're able to go to certain photography stores as well.
Could you use welder's glasses?
I think you could.
Yes, you can. Just make sure that it's 14, grade 14, and that's perfectly fine. That's just standard.
Is there anything else you'd like to add before we wrap things up here?
I'm sending hope out to everybody else in Texas, like ourselves. It's really touch and go, but during the course of this interview, we've gone from feeling actual raindrops to seeing patches of blue sky, so there's always hope.
And I'm just waiting for my 14th total solar eclipse. I actually can't believe that we're 2 days away. It's something that I've been counting down for so long, and it almost feels like it's unbelievable that we're here in Texas. And I still won't really believe it until I get that first contact. That's when, to me, I just think, right, this is actually happening. It's now. The time is now. So I'm looking forward to that particular moment.
And I guess, should everyone see a total solar eclipse at some point?
Yes!
Absolutely, unquestionably. You've heard both of us say that we were unprepared for the experience, that anything that you read about it, any video that you see or picture that you see does not prepare you, because it's not just something that you see. As Kate has said, it's something that you feel, that's inside you, that's all around you. And, it may surprise you just how much it blows you away.
Yeah.
Well, before we wrap up, We just want to mention that on Monday, during the total solar eclipse, we will be doing our best to give you the on-the-ground experience. We have an astrophotographer here who will give us a close-up of the sun, and we'll be on the ground able to answer more of your questions about the eclipse while it's happening. And if you have other questions in the meantime, you can comment on any of our eclipse-related videos or DM us, and we'll try to answer all of your questions. Thank you for joining us. Thank you, Dr. Kate. Thank you, Clara. We really appreciate it, and we hope to do more lives like this soon. Thank you.
Thanks. Enjoy.
All right.